Good morning. It's June 16th, and this is your daily brief in science. Here's everything you need to know. A global push to digitize plant and fungal collections is turning cupboards into digital records, speeding research on climate-resilient wild relatives of crops and aiding conservation worldwide. A century-spanning study of 8 million specimens shows flowering times shifting on average about 2.5 days per decade, with larger changes in the tropics that could affect plant-pollinator relationships. AI and digital tools are helping researchers identify new species, reveal extinctions, track climate-driven changes in flowering and fruiting, and map biodiversity loss, particularly in challenging tropical and Arctic regions. The work also highlights underreported contributions from collectors and communities and suggests conservation gains from international cooperation and ongoing digitization. Technology is described as nature's ally, exposing knowledge gaps and guiding urgent conservation actions through AI, digitization, and global data sharing. AI helps prioritize species for conservation, correct misidentifications, and reveal hidden biodiversity, though data gaps remain a major challenge. Fewer than 16% of herbarium specimens have been imaged digitally, with pronounced gaps in the Global South, leading to biased conservation decisions and incomplete models. Regional blind spots exist, with notably low imaging in the Global South and in countries like Honduras and Nigeria. Digitized records and statistical models can accelerate taxonomy and extinction risk assessments, addressing underreported biodiversity loss. The report emphasizes that AI, digitization, and international collaboration can dramatically enhance knowledge, conservation, and equitable access to biodiversity data, underscoring the urgency of ongoing discovery and protection. A hopeful message: coordinated international action and advanced technologies can boost knowledge sharing and conservation outcomes globally, using digitized assets to uncover new species and assess extinction risks more effectively. Kew's State of the World's Plants and Fungi report highlights AI, data sharing, and global coordination as keys to advancing conservation and knowledge, leveraging digitized assets for global benefit. A tiny breakthrough in in-body sensing could redefine how we track core temperature. MIT-led researchers unveiled MITS, the smallest ingestible thermometer to date, about the size of a blueberry, designed to measure core body temperature from inside the GI tract. The device aims to reduce obstruction risk and improve swallowability while delivering high-precision readings. MITS is described as a scalable, ultra-low power sensor that can provide continuous internal temperature monitoring with broad clinical and operational implications. Funding for the project comes from DARPA, ARPA-H, and the 711th Human Performance Wing, with researchers noting that the views are their own. The work is documented in Nature Electronics and involves collaboration as development moves toward broader clinical and consumer applications. The wireless system emphasizes ultra-low power use, with data potentially gathered through backscattering to an external high-frequency antenna and readings updated about every second. Long-term monitoring scenarios include endoscopic deployment, daily wireless data collection, and GI transit from stomach to excretion over several days, even under harsh GI conditions. Potential applications include infection monitoring, perioperative thermoregulation, fertility studies through core temperature, and at-home fever or performance monitoring for athletes. The device supports possible multimodal sensing in the future, such as pH, pressure, and biochemical markers, and researchers are exploring veterinary and environmental monitoring as well. Validation in animals showed accurate continuous temperature data transmission, both under anesthesia and during movement, aligning closely with gold standard measures. Data security is emphasized with encryption to protect health information, and the approach suggests energy harvesting or micro-battery support for sustained operation. Neutrophils are now shown to limit the effectiveness of immunotherapy by upregulating PD-L1 through interferon gamma signaling in the tumor microenvironment. In mouse models of melanoma and breast cancer, removing neutrophils leads to smaller tumors and greater cytotoxic T-cell activity within tumors, boosting immunotherapy efficacy. The researchers suggest that combining immune checkpoint blockade with strategies to counter neutrophil-mediated suppression could improve patient outcomes. The study is an international collaboration across Sweden, the United States, Germany, and China, funded by NIH, the Swedish Cancer Society, and the Swedish Foundation for Strategic Research, with researchers reporting no conflicts of interest. The findings were published online June 15, 2026 in Immunity, in a paper titled Neutrophil Regulation of Immunotherapy for Cancer is Controlled by Type 2 Interferon. The study by Pei and colleagues, with DOI 1.01016.jimuni.2026.05.014, details how neutrophil regulation of immunotherapy is driven by type 2 interferon. Analyses of tumor samples from lung cancer patients receiving immunotherapy show similar PD-L1-related neutrophil mechanisms, indicating translational relevance to humans. The work reframes neutrophils as modulators of adaptive immunity within the cancer context, shaped by the tumor microenvironment during therapy. Clinically, the findings point to depleting neutrophils, inhibiting neutrophil-induced PD-L1, or altering interferon gamma signaling to augment current immunotherapies. A new study suggests that recipients of an investigational mRNA influenza vaccine may develop a broader and more durable antibody response than those who get standard flu vaccines. Washington University researchers analyzed Moderna's mRNA 1010 in a 2-season study with 75 adults and found higher flu-specific antibody levels and more memory B cells than Fluarix. The data indicate antibodies from mRNA vaccine recipients recognize a wider and more diverse set of flu strains over decades, potentially reducing vulnerability to drifted or mismatched strains. The work is being watched closely as FDA decisions and ongoing surveillance will determine how these findings apply across diverse populations and over the long term. Experts say expanding immune breadth could outpace viral evolution and lessen the need for frequent revaccinations, potentially easing the seasonal flu burden. If approved, Moderna's vaccine would be the first influenza shot to use mRNA technology. Researchers note that broader, diverse B-cell activation may lessen strain mismatch issues and could lower hospitalizations and deaths during flu seasons. The findings highlight how mRNA platforms enable quicker updates to vaccines in response to emerging strains, improving resilience to evolving flu seasons. This study supports the potential for broader, longer-lasting protection from mRNA flu vaccines and their role in epidemic preparedness. Pasithea is advancing PAS-004, its lead NF1 candidate, a next-generation macrocyclic MEK inhibitor in Phase 1/1b for NF1-associated plexiform neurofibromas and Phase 1 for other cancers, with regulatory milestones shaping its development timeline. FD, a fast-track and rare pediatric disease designations highlight potential for accelerated development, complemented by an FDA orphan drug designation in ALS and a newly appointed chief medical officer to steer clinical efforts. Conference outreach is active, inviting attendees to schedule meetings in advance to discuss PAS-004, as the NF conference remains a premier forum for NF1, schwannomatosis, and NF2-related schwannomatosis research and collaboration. Pasithea will also exhibit at the Children's Tumor Foundation 2026 NF Conference in Denver, June 26-30, to engage with the NF1 clinical and academic community about PAS-004. The company frames its strategy around directly engaging the NF1 community to pursue safer, longer-term therapies and to foster collaborations with CTF and NF1 researchers, alongside ongoing regulatory progress and financing updates. Investors are being kept informed through Patrick Gaines of Pasithea, available via email for inquiries. Plexiform neurofibromas are NF1-related tumors with potential morbidity and risk of malignant transformation, providing the clinical context for PAS-004. The release includes standard forward-looking statements and risk disclosures about regulatory uncertainties and clinical development timelines. The stock context indicates KTTA momentum, driven by positive regulatory milestones and company-specific progress rather than broad biotech sector movements. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.